It starts as a tiny chip of crystal that glows blue and ends up lighting your room for 20 years. This is how an LED bulb is made. You flip a switch, and the room fills with light. It happens so fast, you never even think about it. But this little bulb is hiding something strange. It makes light in a completely different way than the old bulbs did. For about 100 years, bulbs made light using heat. A thin wire glowed white-hot inside the glass. But almost all of that energy escaped as heat, not light. An old bulb was really a tiny heater that happened to glow. The LED bulb threw that whole idea away. It turns electricity straight into light, with barely any heat at all. At its core is a chip smaller than a grain of rice. This little chip is the LED itself. LED simply stands for light-emitting diode. It begins life as a crystal, grown inside a hot reactor. Hot gases flow in, and the crystal builds up layer by layer. The crystal is made mostly of a material called gallium nitride. It grows on a flat, shiny disk called a wafer. Thousands of tiny chips are built on a single wafer at once. The wafer is then sliced into all of those separate chips. Each finished bulb will hold only a few of these crystal specks. Inside the chip are two thin layers of crystal, pressed together. One layer is packed with spare electrons to give away. The other layer has tiny empty spaces, waiting to be filled. When power flows in, electrons rush toward those empty spaces. And each time an electron drops into a space, it spits out a flash of light. That is light made directly from electricity. No fire, no glowing wire, just electrons jumping a gap. But here is the strange catch. This crystal can only make light in one color, a deep blue. And for years, a blue chip alone could never make white light. White light is really many colors mixed together. So engineers needed a clever trick to fix it. They coat the blue chip with a thin layer of yellow powder. This special powder is called phosphor. When blue light strikes the phosphor, the powder glows yellow. Blue light and yellow glow then blend together in your eye. And that simple blend is what we see as clean white light. By changing the phosphor, makers can tune the light warm or cool. Now, these tiny chips have to become a real bulb. The chips are placed onto a small circuit board. A machine sets each one down with incredible precision. Hair-thin wires connect every chip to the board. The board is heated until all the connections lock into place. Now, a cluster of little lights sits in a neat ring. This board is not built on ordinary plastic. It sits on a layer of metal, usually aluminum. Because even though LEDs run cool, they still make a little heat, and heat is the great enemy of an LED's long life. So the metal pulls that heat away from the delicate chips. The board is fixed onto a bigger metal piece, the heat sink. You can often see its ridged metal sides on the bulb. Those ridges hand the heat off into the open air. But the chips cannot run on wall power directly. The electricity in your home is strong and constantly switching back and forth. An LED needs gentle, steady, low-voltage power instead. So every bulb hides a small circuit called the driver. It is a tiny board crowded with little electronic parts. The driver tames the wild wall power into a smooth, safe current. It is the quiet little brain tucked inside the bulb. Next comes the base, the part that screws into the socket. It is the familiar metal screw, or sometimes a pair of pins. The driver is folded neatly inside this base. Two wires carry the power up from the base to the board. Then it is all sealed into a sturdy housing for safety. The bulb still needs its smooth, rounded cap. This is the soft, white dome you see on top. It is made of frosted plastic or glass. Up close, the bare chips are tiny, harsh points of light. The dome spreads their glow into one soft, even shine. It is snapped over the board and sealed shut. Now every piece finally comes together. The chipboard on top, the heatsink in the middle, the driver and base below. The dome caps it all off, and the bulb is whole. What feels so simple is really many parts hidden in a small shell. But no bulb is allowed to leave until it is tested. Each one is switched on to make sure it lights. Machines measure its exact color, its brightness, and its power use. The chips are even sorted by color in a step called binning. Some bulbs are left burning for hours to catch early failures. A good LED bulb can keep glowing for 25,000 hours. That is more than 20 years of normal evenings. The bulbs that pass are cleaned and boxed up. They travel out to the shops and then to your home. You screw one in and flip the switch. And now you know the real secret behind that instant light. A speck of blue crystal, a dust of yellow, and a clever little brain. It was never just a bulb. It was made. Now it's your turn. What should we build next? Drop it in the comments. The most liked idea becomes our next video. See you there.